Hi class, today we're going through our note on solving rational inequalities. So I'm going to show you guys how to do this on GeoGebra and also how to do it by hand. Okay, so it's a bit more complicated than just solving rational equations. You can't just cross multiply anymore. So you might want to put like in big letters at the top of your page, cannot cross multiply. With solving equations, rational equations, you can, but with inequalities, you cannot. So it adds an extra layer of difficulty. There's not a lot more analysis, okay, in this note than in the last. So to solve a rational inequality means, well, if you're doing it algebraically, you're finding the ranges of the x values that satisfy the inequality. So take a look at example 1. You're finding what values of x make this left side smaller than the right side. So there isn't just going to be one answer, there's going to be a range of answers. Okay, graphically it means to graph each rational function and find the points of intersection and then find where it's above or below. So we're going to graph x over x plus 7 and negative x over x minus 2 and see where they intersect and see where this left hand side is below the right hand side. So let's do GeoGebra first. So the question is asking, when is this green function? So there's the green function. Notice it has a vertical asymptote at negative 7, okay? And it has a horizontal asymptote at 1, all right? When is the green one less than this red one? So the red one has a vertical asymptote at 2 and a horizontal asymptote at negative 1. So visually we can see that the green in this section, so less than negative 7, the red is below the green. So that section wouldn't apply. But right after the asymptote, the green function is lower than the red function up until a point of intersection. Then there's this little bit of space where green is above, so that wouldn't be included in our solution. And then there's this little space though where green is below the red function again until we hit this asymptote, and then the green is above the red forever. So if you zoom in on this section, really we're trying to find these points of intersection so we can say it's between negative 7, which is where the asymptote is, and whatever this point of intersection is. And then it looks to be about minus 2.5. But we don't know if it's exactly that or if it's some other fraction. And then it looks that they intersect again at 0, 0. So between 0 and then 2, because that's where this red function dips below again. So we need to find these points of intersection. So on GeoGebra, you can go to the CAS, remember, that's this app, CAS, and type this equation in. So we would have x over x plus 7 equals, and then over equals, and I'm going to put in brackets negative x divided by x minus 2. Okay, now remember, don't press enter, you press this x equals button, and it's going to solve the equation. Oops, there, it solved it. Okay, so notice that x equals negative 5 over 2, and x equals 0 are the solutions to this problem. So those are the two x coordinates there. So if we go back to this, that confirms that this is minus 2.5 and this is 0. So our answers then would be the green is less than the red between negative 7 and minus 5 over 2 and between 0 and 2. Okay, so that's how we do it graphically. So now let's go through and do it algebraically. Okay, so as I said at the beginning, we cannot cross multiply. It really stinks, but we can't do it because the vertical asymptotes are still relevant. Okay, if we cross multiply, it kind of gets rid of the fact that there are vertical asymptotes because it puts them up in the numerator. Now, with just solving the points of intersection, that didn't matter, but for finding intervals of greater than or less than, it does matter. Okay, so what we need to do is put this guy over to this side, so they're all on one side together. So you're going to have x over x plus 7 plus, once you move it over, okay, because this is a minus here, plus x over x minus 2 is less than 0. So you want to arrange so everything is over on one side and you have 0 on the other side of the inequality. So the next step is to get a common denominator and simplify the left side. So that's a plus there, in case you didn't know. So our common denominator is x plus 7 and x minus 2. So this one gets multiplied by x minus 2, and this one by x plus 7. And they're all over the common denominator of x plus 7 and x minus 2. Okay, you don't want to actually FOIL the denominator. You want to leave it like that because that shows us our vertical asymptotes. So leave it in that form. But you do want to expand and collect like terms on the top because there's still this addition. So once you do that, you get 2x squared plus 5x. Okay, all over x plus 7, x minus 2. And so you have that less than 0. So now you're solving this inequality, which is saying when is this function below the x-axis? Okay, so to do that, we go back to our little trick with positive and negative intervals. So basically we just, oh, there goes my copy. Basically we just need to determine the positive and negative intervals of this function, and that will solve our question because we just want to know when it's negative. So we have to check on either side of the zeros and the vertical asymptotes. So the zeros we can find by setting the numerator to 0. Okay, so you can just actually take out an x and you're left with 2x plus 5. So then the zeros there are x equals 0. And x equals negative 5 over 2, oops, which we recognize those two numbers from the solutions we found on GeoGebra. So we're on the right track. Okay, now the vertical asymptotes are negative 7 and 2. So therefore, if we were to draw a really rough sketcheroo here, we would have a vertical asymptote here at negative 7. Okay, you don't have to be formal with this at all. A 0 at negative 5 over 2, an x-intercept at 0, and another vertical asymptote at 2. So this is 0, this is negative 5 over 2. So I have these many sections. I have section 1, so below 7, so x is less than negative 7. And if this work, that would be even better. Okay, I have this section between this asymptote and this 0. Okay, so I'm going to check between minus 7 and minus 5 over 2. And then I got to check in between here what's going on. So between minus 5 over 2 and 0. And then I got to check between 0 and 2. It's exhausting. And then finally, x is greater than 2. So I have to check in all of these intervals whether the function is positive or negative. Okay, and then I'm looking for any of the negatives. So anywhere where it's negative, that's going to be the solution to my inequality because that's what I'm trying to solve. When is this function less than 0? Okay, so now you can just use, notice how I put the function here in factored form. When it's in factored form, it's actually quite a bit easier to determine if it's positive or negative, and I'll show you why. So for less than negative 7, you can put in a number negative 8 and just see what pops out. So if it pops out negative, then you can say it's negative. Or you can kind of just think in general. If a number was less than negative 7, then x would be negative, so that's negative. 2x plus 5 would be negative as well because minus 7 is so that would be negative. So you'd have two negatives on the top, a negative times a negative. All right, and on the bottom, x plus 7, well, if your x is less than negative 7, that's still going to be a negative number. And x minus 2 is going to be negative. So you're going to have negative, negative, so positive over positive. So this actually ends up being positive here. Okay, and now you go through and do the same thing here. So between minus 7 and minus 2.5, x is negative. 2x plus 5 is still negative. But now x plus 7 is going to be positive, right? Because like minus 5 plus 7, that's 2. But minus 2, that's still going to be negative. So now you're going to get a positive divided by a negative. So this ends up being negative. So there's a negative interval. Okay, between minus 2.5 and 0, x is still a negative guy. Okay, 2x plus 5. So let's think about if you have like minus 1, that'd be minus 2 plus 5. So that becomes positive now. And then x plus 7 is positive. What is going on? Seriously? I don't know what's happening. Okay. Positive. My gosh, I'm losing my mind. X plus 7 is positive, and x minus 2 is negative. Okay, so you have a negative divided by a negative, so that becomes positive. Let's see if we can keep going. Okay, if your x is between 0 and 2, then x is positive now. 2x plus 5 is positive. X plus 7 is positive. But your x minus 2 is still going to be negative. Because if it's between 0, that looks terrible. I'm really sorry, guys. It might be behind my head anyway. Okay, so x plus 7 is positive, and x minus 2 is negative. So you're going to have a positive over a negative, so it's going to be negative there. And then greater than 2, all 4 of these factors are positive. Hopefully that makes sense to you. So that interval is positive. So in this example, it goes positive, negative, positive, negative, positive. So you might say, well, if the first one is positive, Mrs. Weeds, can't I just follow the pattern? No, rational expressions are not that predictable. So you actually have to go through and test all of the intervals. But now I can make my conclusion because I'm looking for when this function is negative. So these two intervals are my answers. So my final answer then is, to the original question is, when x is between -7 and -5/2, and when x is between 0 and 2. So this is the solution to the original inequality, which is right here. That's the solution. So if you put in any x values within these ranges, the inequality will be true. If you put in any x values that aren't within those ranges, the inequality will be not true. Okay, so now we go through the exact same method for example 2 and example 3. Okay, so our first step is to rearrange so everything's on the right side. So we have x minus 2 minus 8/x is less than or equal to 0. Okay, step 2, we get a common denominator, which is x. So we have x squared minus 2x minus 8 all over x is less than or equal to 0. Okay, now it's beneficial to factor the numerator if possible, because then we can see the zeros of this function quite easily. So in this case, that would be x plus 2x minus 4 all over x is less than or equal to 0. Okay, now I can identify that my zeros are x equals -2 and x equals 4, and I have a vertical asymptote at x equals 0. So now I'm going to go ahead and set up my chart here so that I can determine where this function is negative and where this function is positive. So if you're a visual person like me, you might want to set up a little sketch so you can just visualize. Okay, there's my sketch. So I have a vertical asymptote here at 0, and I have an x value at -2 and at 4. Okay, so that just helps me visualize to set up the chart. I know it's weird and ugly, but it just helps me. So I have to look for x less than -2, x between 0, x less than -2, between -2 and 0, between 0 and 4, and then greater than 4. Okay, and I'm looking at the function f at x. I'm just looking if it's positive or negative. So I'm just making this really informal chart here that will help make my decision. Okay, so less than -2 on the top, I'm going to have x plus 2 will be negative, x minus 4 will be negative, and my denominator will be negative. So that gives me a positive divided by a negative. So this is a negative interval. Okay. Between -2 and 0, then x plus 2 would become positive. X minus 4 is still negative, and x is negative. So in this case, I would have a negative over a negative, which is a positive. Okay, between 0 and 4, x plus 2 would be positive. X minus 4, though, would still go negative, right? Like 3 minus 4 still gives you a negative number, divided by a positive. So in this case, I'd have a negative over a positive, so that's a negative interval. Finally, greater than 4, everything's positive, life is good. So I have positive. Okay, so now I got to be careful with my answer. So I'm asking, when is this function less than or equal to 0? So it's less than 0 before -2, and it's equal to 0 at -2. So my solution will include all x less than or equal to -2, because -2 is an x-intercept. If -2 is a vertical asymptote, that wouldn't work because it can't be equal to -2, right? So I can think about my function that will include 2. Okay, between -2 and 0 is positive, so that doesn't work. But between 0 and 4, it's negative again. Okay, but at 0, that's an asymptote, so I can't include it in my solution, but I am including 4 because that's an x-intercept. And again, my question was asking for less than or equal to 0. Okay, if this was just less than, then I wouldn't include this, but it's less than or equal to 0, so that takes a bit more thinking on my part. So that's the solution. So any x values within those ranges, if I subbed it into this inequality, the inequality would be true. Okay. If you're brave enough, I'd encourage you to pause the video and try example 3 on your own, see what you can do. Okay, remember, you're going to look at this and you're going to want to cross multiply, but you can't with inequalities. You have to move everything over. So you get x plus 3 over x plus 1 minus x minus 2 over x minus 3, all greater than or equal to 0. All right, and now I've got to do some algebra. So I got to get my common denominator. So I get x plus 3, x minus 3, minus x minus 2, x plus 1, all over my common denominator, x plus 1, x minus 3. And I want that all to be greater than or equal to 0. Okay, so just be careful when you're expanding here with this negative, okay? When you FOIL, keep that all in brackets so that that negative is distributed amongst that whole bracket. So when you rearrange this, you get x squared minus 9 minus bracket x squared minus x minus 2. I'm just showing this extra step because this negative I know is a bugger. And remember, just leave the bottom factored because then you can see the vertical asymptotes. Don't FOIL the bottom. So when you rearrange this, the x squareds actually go away. And so this negative x becomes a positive x, and minus 9, and then that's plus 7. So you get x minus 7 all over x plus 1. So this is the 7. X minus 3. All right, greater than or equal to 0. So now I got to do my really awesome sketch, which I know you guys just love when I sketch things. So I have a 0 at 7. And I have a vertical asymptote at -1 and at 3. All right, so I am testing section 1, section 2, section 3, section 4. So x is less than -1, and then between -1 and 3, between 3 and 4, and greater than 4. Oh, sorry, 7. That's a 7. Greater than 7. That's what you should label that, Weens. That's a 7. All right, so less than -1. What do I got? I got negative on the top divided by, that's negative. That's negative. So I get negative over positive, which is a negative interval. Okay, between -1 and 3, on the top, I still have a negative number. X plus 1, oh, now that becomes positive, but this -3 is still negative. So now I have a negative over a negative, positive interval. Life is fantastic. Okay, between 3 and 7, this x minus 7 will still be negative. X plus 1 is positive, and now x minus 3 is positive since all our values are above 3. So when you subtract 3, it's still positive. So negative over positive is a negative interval. Greater than 7, everybody's happy now. Everybody's positive. So that's a positive interval. So that means this question that was looking for greater than or equal to 0. So I'm looking at positive intervals. So that's between here, it's positive, and here it's positive. So I got to make sure I'm answering this properly. Now, it's between -1 and 3. Do I put inclusions here? Because look, this had an inclusion. Do I put inclusions here? I can't because they're asymptotes. Okay, but I can on greater than 7, greater than or equal to 7, because that's a 0. So it does actually equal 7, but they can't equal -1 and 3. So that is your solution. Thanks for watching, guys. Hope you learned lots.